Good morning, everyone. My name is Iksan Bukhari, and I'm here to talk about our submission to InventX 2026. The project that we submitted is titled GADCHE, which stands for Genetically Adapted Dual Cut Histogram Equalization. This is a novel contrast enhancement techniques for brain MRI images. Our team consists of myself, Iksan Bukhari, Cox Wisim, Kok Penggan, and Nur Azlina binti Abdul Aziz. Our proposed approach actually consists of two parts. The first one is the dual cut histogram equalization, or DCHE. In this method, we determine two cutting points of the histogram of our brain images. And after we provide these two cutting points, which practically divides the histogram into three regions, we apply histogram equalization asymmetrically between these three regions with the hope that the contrast will be enhanced by equalizing these histograms. And this is the general algorithm of this DCHE. But then we went a step further by trying to use the genetic algorithm to optimize this M1 and M2. And here is the general pipeline of this technique. The original image being passed through the pre-processing and then passed through the DCHE, where we implement GA optimization to find the best M1 and M2 based on fitness function, which depends on both the contrast entropy, represented by this EME, and the image quality, represented by the SSIM and PSNR, with the hope that the output of this pipeline is going to be the better, more contrast and image of the brain. And to show you how this works, here we provide a little demo using a simple GUI. So let's take maybe two examples. So here's the brain MRI image of a tumor patient. As you can see, the region of the tumor here is a little bit close in brightness with the brain tissue. So if we implement our proposed pipeline, here you see the tumor is much more prevalent. Okay. Now, our proposed pipeline does not only work for tumor brain image, but also here we have one MRI image of a stroke patient. And as you can see, the field region here is very similar to the rest of the brain tissue. But let's try to implement our contrast enhancement. And now you can see, besides the skull region, the field region of our brain image is highlighted better so that it's easy to find where the field region is. So that's a little bit of a demo of our proposed technique. And here are the results where we actually implement our techniques against many other contrast enhancement techniques on several hundreds of images. Here, the top row of the figure represents the contrast entropy, and the bottom one represents the quality of the image. As you can see, the contrast entropy for our method is much higher than the others, but the image quality, even though it's not as high as some of these approaches, but still can compete with them. And here's the visual result of our proposed approach. And here are the patent, copyrights, and publication related to this project. Now, further down the line, the applications on which we can implement this proposed pipeline can be in the online classification and segmentation, where each one of the image being passed through our GADCHE and then go into multi-class classifier to classify healthy and ill brains, yeah, and then continue with the segmentations. Or offline classifications, where we enhance a bunch of images first and then pass them one by one to the multi-class classifier and then the segmentation. And that is it about our project. Thank you very much and good morning.